Hi everyone, I'm Elvis from the Engineering Success Center, and today I'm going to be making a video uh, to introduce you guys to Arduino. Um, I understand that you're just beginning your Arduino part of your programming course, so I'm just going to be going over some things that I wish I knew in my first year um, with respect to Arduino. Okay. So this is the outline. I'm going to be going over what an Arduino is, like common uses of Arduinos, the different types of Arduino boards, and the parts of the Arduino boards and their functions. After that, I'm going to briefly explain how to use an Arduino in terms of programming in the Arduino IDE and then setting up like circuits. And then after that, I'm going to be going over things I wish I knew in my first year with respect to Arduino programming, uh, which are debugging and Tinkercad. So what is an Arduino? An Arduino, oh, mistake. An Arduino, for our intensive purposes, is the brains of our operation, and it's a small computer that we can program to do things that we want it to do. That's just a general overview of what an Arduino is. Okay, so common uses of Arduinos. There's many uses of Arduinos, like prototyping, like if you have a design and you want to prototype it, see how it works, you can use an Arduino. For DIY projects, if you want a thing, a device that does something but isn't on market and you want it to be able to, you want to build one, yeah, you can use an Arduino. And basically anything you can come up with, honestly. I'm gonna show you guys a video of what I've used an Arduino for. So this is groundy. That's what I like to call it. One second, pause. It was a project for Intro to Mechatronics. This was the final project for Intro to Mechatronics. So it's basically an obstacle avoidance robot, but it uses an Arduino Mega as the brains of the operation. And it also uses a bunch of sensors, but you'll get into that later. But I'm just showing you kind of a shameless plug, honestly, but it's just showing you what an Arduino is capable of doing for those who don't know. Yep, and that's groundy. Okay, so that's a common, not very common use of an Arduino. Actually, it's quite common. Okay, so the different types of Arduino boards. There are different types of Arduino boards. On the left, we have a Nano. In the middle, we have a Mega, like the one I used to make the robot in the previous video, and a Leonardo on the right, which is probably what you're going to be using in your course for um, engineering programming with computer programming with engineering applications. Okay, so parts of an Arduino and their functions. So there's many parts of an Arduino. The USB, this is what you can use to connect the Arduino to your computer. Um, you have your power. So it takes the power from your computer and splits it into three different bands, like 5 volts or 3.3 volts. Usually, um, 5 volts is more common. Most of the time, most of the projects I've used Arduinos for, I've used the 5-volt pin. So it's just voltage to power your different sensors or your breadboard or whatever. And then you have ground pins. You have quite a number of ground pins, and it also depends on the kind of board you're using. So this is an Uno, and it has 1, 2, 3. It has 3 ground pins, but obviously, if you connect this to a breadboard, you can have as many ground pins as you want. Um, so this is a power input in case you're powering your Arduino differently. Say you're not using your USB, say you've programmed it and you have it in an application, you have a power input for that. So then after all the electrical stuff, you get into the different kinds of pins. So there's analog ins, analog input pins. Usually those read analog signals from sensors, and those are very important. You have 5 of those. It also, that depends on the board. Obviously, the Mega would have more pins. That's why it's called the Mega. So after that, you have pulse width modulation pins. I don't know if you've heard of pulse width modulation, but you will. Um, it's just, I'm not going to go into it in this video, but you're going to hear a bunch about pulse width modulation in the coming weeks and possibly years. Those are digital pins, and it just, you can use them as digital pins. So basically on or off. But with the pulse width modulation pins, it's not just on or off. You can kind of set it to go in between, using the duty cycle between 0 and 100. So yeah, and yep, power indicator, some LEDs, and yeah, the Arduino itself works based on like a small chip, which could be the Atmega, uh, whatever. There's different types of chips, but you don't really need to know that right now. If you're interested, you can learn more about it. But those are the basic parts and functions of an Arduino. So how do you actually use an Arduino? This is another shameless plug with my messy wires and things, but it's just, you can use an Arduino in many ways. And this is just one very messy way to use an Arduino. Okay, so programming, which is going to be the majority of what you're going to be seeing in your course. Arduino, to program an Arduino, you basically have to use the Arduino IDE, and it makes it really cool. It makes it really easy to program that way, because that way you can just interface with the Arduino from this one place, and you can write your code, upload it to the Arduino, debug, and do everything in that one workspace. So that's the Arduino IDE. And so there's different types, well, there's different parts of the code for an Arduino program. You have the variable declaration section, which is at the top, where you define what your variables are over here. And then you go into the setup, which is where you define things like what pin is going to be an output, what pin is going to be an input, and other things like that. And then you have your loop section, where you actually, that's the actual code that the Arduino runs over and over and over again. Whereas the setup section is just going to run it once. and then it goes into the loop section where it just runs continuously. Yeah. Cool. Okay, setting up circuits. So when you use an Arduino, you need, I guess you need a fundamental understanding of electric circuits and how they work to be able to interface them or design the circuit to fit your application and whatnot. The picture here just shows how you would use a breadboard to connect a circuit as shown uh, in the schematic diagram. So these are just 3 resistors in parallel, and how you would connect them to be the exact same thing, but using a breadboard is as shown in the picture below that. So how breadboards work, um, they're just a bunch of connection points, but they're connected in a specific way. So if, because of the orientation, I'm just going to say vertical, all the pins in the same vertical column are connected. So except they not across this space, just on either side of this double line, they're connected together. So that's why you can have this connected to this and also connected to this as well. So it's basically like the same node, if that makes sense. You'll get more understanding of this the more you do prototyping and the more you work with Arduinos, that's for sure. But this is just a basic example of how it would come together, how your circuit would look like. Okay, so we go to the fun stuff. Things I wish I knew in my first year about using Arduinos. Um, so first, debugging. Debugging can be a massive pain because it could take anywhere. You can't really tell how much time it's going to take you to debug your program. Usually that depends on like the complexity of the program, how you decided to write the program. But other times it could be things that are not in your control. Like for instance, there was a time when me and a friend were working on a project last year, and his DC motor was flipping directions when in the code it was not supposed to. And then we found out that the reason why was because his computer was plugged in as opposed to my computer that was not plugged in. And just little random things like that could make debugging a horrible experience at times, but other times it could be just a missing semicolon. So that being said, uh, the main advice I can give anyone in regards to debugging would be the following. So practice stepwise debugging, which means don't wait to debug at the end, like when you're done writing your code. You can write your code in little chunks and make sure those little chunks work. So when you get to the end, if you have to do any debugging, you can narrow it down to something very little and find the source of the problem. Yeah, so another thing is when you're using sensors, make sure to refer to the data sheets. The data sheets are usually given when you're given sensors to use, or you can easily find them online, just so you're sure that you're using the sensor in the right way. Okay, the next one would be to use the serial monitor to print out the variable that you suspect is the cause of the problem. This one's quite important because sometimes you might be, well, further down the line, probably you'll be working on something that has to do with a bunch of math. So if if the first equation you write is going to give an answer which is stored as a variable. Um, if you're not sure what the problem is, you can check that variable by printing it to the serial monitor, and that if you can like numerically solve it out by hand and know what the value is supposed to be giving you, and you can tell that it's not giving you that value, then you can know that, oh yeah, for sure that's the source of my problem, and then you can go about figuring out how to fix it. So that's a good piece of advice that I can give. And then you should also know your variable types. This is one other important one that I wish I knew in my first year. So there's different types of variables, um, like integers, floats, doubles, strings, chars, and a bunch. I don't know all the types, but it would be worthwhile to look into uh, what integer or what variable type would best fit what you need that variable to do. So an integer, for instance, is best used for something that's just going to be round, like whole numbers. Like if you're getting a value of 1, 2, 3, 4, 5, or uh, something else, but it's an integer, you can use integer as your variable type for that variable. Um, floats floats can have decimals. You can define how many decimal places as well, um, depending on your application. It might be more beneficial to use a float, but one thing you must note while using floats is that it takes a significant amount of processing power because it has to take into account the extra decimals. But it shouldn't really matter because if you need it to give you a number with decimal points, then you need to use a float and things like that. So I would suggest you do some further like research into the different variable types and know which one would be best for your application. And then another piece of advice I can give you would be to double check your circuit. So ensure that your circuit is accurate and ensure like circuits can get quite messy. I know I showed this a couple of slides back, um, a couple minutes ago actually, but this is a simplified circuit and it could get messy. So just try to stay organized when you're building up your circuit and ensure that your circuit's accurate to what you need it to be. Okay. So another quite important actually, another thing I wish I knew in my first year about Arduinos is Tinkercad. So Tinkercad is like an online resource. It's an online, it's basically a website where you can go and prototype what your circuit's going to be like, or um, what you're trying to do. You can go there and play around with it, set it up, what it's supposed to look like, and then you can also write the code there and run the code and debug the code before you even build anything like physically. So I think it's a very great resource. And on top of that, it provides a different way to approach programming. I'm going to show it in a bit. I'm going to show it right now. So actually, I think I have it open here already. Okay. So this is what Tinkercad would look like. So I just have a circuit set up with a breadboard and a bunch of LEDs, and I have it all connected like like so. Um, Now you can start the simulation, and if you don't have anything in the code, it won't do anything. But I set it, so I kind of programmed it to set everything low and then like strobe the lights. And I did that using these blocks on the right. So it doesn't look quite like a typical Arduino code that I showed earlier, but it it gets the job done. And the fun thing is that you can do it this intuitive way, and then you can also export it to like an Arduino code. Uh, I don't know. Let me see. Blocks plus text. Yeah. So you can kind of see now. So it changes these blocks because I started out using these blocks, and then I said blocks plus text, and then it gives me what the code would be. So you can see the setup in mode 13, output 12, output 11, output, because um, I needed all those pins for the um, I needed all those pins for the Arduino to set up all these LEDs. So now you can kind of see it just writes it out. And then when I go to simulate it, when I go to start the simulation, it basically, oh, I do. Okay, that's fine. Yeah, it still stays connected regardless, but yeah, it doesn't look as nice. But if I start the simulation, you can see what it does. It kind of just goes. And that's pretty neat because I've done all of this. I have the code. If I wanted to make a thing like this, I have the code and I know that it works and does this without actually going to start putting wires in a breadboard and putting LEDs in a breadboard. So it's just a quick way to prototype your circuit and make sure it works before you actually have to put it together. So I think that's pretty cool. I wish I knew that in my first year. Um, yeah. So that brings us to the end of my presentation. I really hope you found this helpful. And as always, I will be in the Engineering Success Center, always waiting and ready to help. If you have any problems with Arduino, don't hesitate to reach out to us. And good luck. I hope to see you soon.